Imagine a clear sky. A perfect day. 66 million years ago, large creatures, the dinosaurs, walk the earth. They are the kings of this world. They have ruled for millions of years. But something is coming. A small point of light appears in the sky. It grows brighter and brighter. This is not a star. A rock from space, 6 miles wide, traveling faster than a speeding bullet. It is an asteroid on a direct course with our planet, a harbinger of unimaginable change and devastation. The asteroid strikes the ocean with incredible force. The impact is 1 billion times more powerful than an atomic bomb. It tears a hole in the Earth's crust, 100 miles wide. A wave of fire and heat expands across the globe. Forests burst into flames. Dust and ash blot out the sun. The sky turns dark. Darkness lasts for months, perhaps years, a time of cold and shadow. The world the dinosaurs knew is gone, erased in a single catastrophic instant. The world enters a new, dark age. Without sunlight, plants wither and die. Herbivores that ate the plants soon follow, starving. Then the carnivores disappear. The great dinosaurs cannot survive this brutal winter. Their long reign ends suddenly and violently. The Earth is quiet, waiting for a new chapter, a reset by a visitor from the stars. But this story of destruction is also a story of creation. From the ashes, new life will eventually rise. The end of one world is the beginning of another. The impact cleared the way for something new. Small, furry creatures leave the shadows and step into the light. This cataclysm is one chapter in a much, much longer story. The story of our planet, constant change, destruction and renewal. Our planet has a very long history. It is a story that stretches back 4.5 billion years. This is a number so large it is hard to imagine. If you were to count every second of your life, it would not come close. If you were to read a book for every year, you would need a library the size of a city. To make this vast expanse of time understandable, we need a map. In this journey, we will travel through this deep time together, step by step, to see how our world came to be. We will explore its incredible past. We will begin our story at the very beginning. We will witness the birth of our planet from a cloud of dust and gas. We will see how a hot, violent world slowly cooled down. We will watch as water arrived, filling the oceans and setting the stage for a miracle. This journey will take us from the fiery origins of the Hadean Eon to the first whispers of life in the ancient seas. We will explore an alien Earth, a world without oxygen, a world of strange chemistry, simple beginnings. Then we will witness the single most important event in Earth's history, the dawn of life. We will see how tiny, simple organisms changed everything. They learned to eat sunlight, and in doing so, they released a new gas into the air. That gas was oxygen. It transformed our world, creating the air we breathe today. This great change paved the way for more complex creatures, animals, plants, the explosion of life in the oceans, and its brave move onto the land, creating the green world we know. Our journey will not shy away from moments of great disaster. We will see how life was nearly wiped out, not just once, but many times. We will travel through ages of ice and fire. We will meet the great dinosaurs, stand in their shadow, and we will witness the day they vanished. We will then follow the rise of the mammals, our own ancestors, and finally, the arrival of humans. This is the complete story of Earth, a story of resilience, change, and our own special place within it. Let us begin. Our story begins a very long time ago, before the Earth, before the sun. There was only a vast, cold cloud. This cloud was made of dust, gas drifting through empty space. It was enormous, larger than our entire solar system is today. For millions of years, it floated peacefully. But then, something disturbed it. Perhaps a nearby star exploded. The shockwave pushed the cloud together. Gravity began to pull the dust and gas into a spinning disk. A spinning disk, the start of everything we know. At the center, material became very dense and hot. Pressure grew and grew, becoming immense. Finally, a star was born, our sun. It lit up the spinning cloud, warming the dust and gas. This new star was the heart of our young solar system. The rest of the material did not fall in. It continued to orbit, swirling around the new star like water down a drain. These were the building blocks of planets, the raw materials for future worlds. Far from the sun's heat, tiny grains of dust began to stick together, like snowflakes, gently bumping and clumping. First, small pebbles. Pebbles collided into larger rocks. Over millions of years, rocks grew into huge boulders miles across. The first small planets, planetesimals, thousands of them circled the young sun, a busy, crowded cosmic construction site. Planetesimals often crashed into each other. Sometimes collisions were gentle, bodies merged. Other times impacts were violent, rocks shattered, a slow, messy process of creation. One growing body became our future home. It gathered more and more material, sweeping its path clean. One of many small worlds fighting for its place in the new solar system, slowly growing larger with each passing millennium. The early Earth was not the blue and green world we know today. It was a hellish place. Constant collisions with other planetesimals generated incredible heat. The entire planet was a molten ball of liquid rock, a glowing ocean of magma. Its surface temperature was hotter than any volcano. There was no solid ground to stand on, only a fiery, churning sea. Heavy materials sank down through the liquid rock, iron, nickel. They moved towards the center, forming a dense, metallic core. This was the Hadean Eon, named for Hades, the Greek underworld. The sky was not blue. There was no air to breathe. A thick, choking atmosphere of steam, carbon dioxide, other volcanic gases wrapped the planet. That atmosphere trapped heat, making the surface even hotter. Meteors, comets, rained down, striking the molten surface. It was a world of fire and violence. Imagine standing on a nearby rock watching. You'd see a glowing red sphere, scarred by bright flashes from constant impacts. Huge gas bubbles rose from the magma, then burst, releasing toxic fumes. No water, no life, no hint of the gentle world to come. This intense bombardment lasted hundreds of millions of years. The planet was growing, but it was a painful, violent birth. Every rock from space was another building block, another scar. Slowly, very slowly, things began to change. Large impacts decreased. The solar system became less crowded. With fewer collisions, Earth lost heat to space. A thin crust of solid rock started to form on the magma ocean. Dark and brittle, like a cooled lava flow. The crust was constantly broken and remelted by volcanic activity. But it was a start. The Earth was beginning to cool, the first step toward a solid world. About 4.5 billion years ago, when the Earth was still young, a truly massive event occurred. It changed our planet forever. A rogue planet, about the size of Mars, was on a collision course with Earth. We call this other planet Theia. It had formed in a similar orbit to our own world, and for millions of years the two planets circled the Sun without incident. But their paths were not stable. Gravity slowly pulled them closer and closer together. A cosmic crash was inevitable. This was not a small impact. It was a world-shattering collision. Theia did not hit Earth head-on. It struck our planet at an angle, a glancing blow of unimaginable power. The impact was so great that it vaporized Theia completely. It also melted a huge portion of the young Earth's crust. Mantle, a colossal cloud of superheated rock. Gas was thrown out into space, forming a ring of debris around our planet. For a short time, our world must have looked like a distorted, fiery ball, surrounded by a glowing ring of its own shattered remains. The ring did not drift away. Gravity took hold and the countless trillions of particles began to clump together. A new body began to form from this ring of rubble. Over a surprisingly short time, perhaps only a few thousand years, this material gathered into a single, large sphere. This new sphere was locked in orbit around the Earth. We had a companion. The Moon was born. The Moon's formation had profound consequences for our planet. Its gravity pulled on the still molten Earth, creating powerful tides in the ocean of magma. More importantly, the Moon stabilized our planet's rotation, acting like a steadying hand and preventing the Earth from wobbling wildly on its axis. This stability gave our world a predictable climate over long periods, essential for the future development of life. The Great Collision that created our Moon was a moment of destruction that ultimately made Earth a more stable and habitable home. After the formation of the Moon, the Earth continued to cool. The crust became thicker and more stable. Volcanoes still covered the surface, pumping huge amounts of gas into the atmosphere. The air was thick with carbon dioxide, nitrogen, water vapor. The intense heat of the early Earth had kept all water in the form of steam. Our planet was wrapped in a thick, cloudy blanket. As the surface temperature dropped, a critical point was reached. The steam in the atmosphere could finally turn back into liquid. Then, the rain began. But this was not a gentle shower. It was a torrential downpour that lasted for millions of years. Water that had been trapped as steam in the atmosphere fell to the surface. It was a global flood of epic proportions. The rain filled the lowest parts of the landscape, the vast basins, craters left over from the age of impacts. Slowly but surely, the first oceans began to form on the surface of our planet. The hot, dark rock of the new crust hissed and steamed as the first drops fell. Where did all this water come from? Some of it was released from the planet's interior by volcanoes. When rocks melt, they release the water trapped inside them, and this was vented into the atmosphere as steam. But many scientists believe that much of our water was delivered from space. During the early bombardment, Earth was constantly hit by comets, asteroids. Comets are like giant, dirty snowballs made of ice and rock. Each one that struck our planet was a delivery of water from the outer solar system, adding to our planet's growing supply. By about 4 billion years ago, the Earth had become a water world. Vast global oceans covered almost the entire planet. The continents we know today had not yet formed. There were only small volcanic islands poking out of the endless sea. The sky was still filled with thick clouds, and the sun would have been a dim light. The water in these early oceans was hot and acidic, filled with dissolved minerals from the rock. It was a strange and alien world, but it now had the single most important ingredient for life as we know it: liquid water. The stage was set for the next miraculous act. Our planet was now a world of water. The endless rain had stopped, and a vast, warm ocean covered the globe. This ancient ocean was a chemical soup. It was filled with simple molecules, many delivered by comets or created by lightning-striking volcanic gases in the atmosphere. For millions of years, these chemicals floated and mixed in the water. They were the raw ingredients for life, but they were not alive. Something incredible had to happen to turn this non-living chemistry into the first living thing. The jump from chemistry to biology is perhaps the greatest mystery in the entire history of our planet. This first spark of life likely happened deep beneath the waves. Here, on the ocean floor, were hydrothermal vents. These are like underwater volcanoes, spewing hot, mineral-rich water from inside the Earth. Around these vents, the conditions were perfect. There was a constant supply of energy and a rich mixture of chemicals. In these dark, warm places, simple molecules could have linked together to form more complex structures. They began to form long chains, capable of storing information. These were the ancestors of DNA, the instruction manual for all life. This process was incredibly slow, a game of chance played out over millennia. At some point, around 3.8 billion years ago, a crucial step was taken. Some of these complex molecules became wrapped inside a simple membrane like a tiny bubble of oil. This bubble protected the molecules inside. It created a separation between the inside and the outside world. This was the first cell. It was not truly alive yet, but it was a container, a tiny laboratory where the chemistry of life could become more organized. Inside this protective barrier, the molecules could work together, becoming more efficient and more complex, sheltered from the chaotic ocean around them. Finally, one of these simple cells achieved something new. It developed the ability to make copies of itself. It could take the raw materials from the ocean soup and build a duplicate. This was the moment life truly began. The first living organism on Earth was a simple, single-celled microbe. It was smaller than a grain of sand, but it was alive. It could eat, it could grow, and most importantly, it could reproduce. From this one single ancestor, every living thing that has ever existed on our planet would eventually descend. Life had gained a foothold in the ancient ocean. Section 2. The Blue-Green Revolution. For hundreds of millions of years, the first life forms had a simple existence. They floated in the warm oceans, absorbing the chemical nutrients around them. They lived in darkness, either deep in the sea or hidden from the sun's harsh ultraviolet rays. The sun was a source of danger, not a source of energy. The Earth's atmosphere still had no oxygen, and therefore no ozone layer to protect the surface from deadly radiation. Life was confined to the shadows, surviving on the planet's leftover chemical energy. It was a successful strategy, but it was limited. A great breakthrough was needed for life to truly flourish and expand. That breakthrough came around 3.5 billion years ago. A new kind of microbe evolved. These were the cyanobacteria, sometimes called blue-green algae. They performed a new and revolutionary trick. Instead of getting energy from chemicals in the water, they learned to get it directly from sunlight. This process is called photosynthesis. It was a biological masterstroke. The sun provided a limitless, free source of energy. These tiny organisms could now make their own food just by floating near the surface of the water, basking in the light. This new ability would change the world forever. Cyanobacteria began to spread across the globe. They formed huge, slimy mats in the shallow coastal waters. We can still see the fossils of these mats today. They are called stromatolites, and they look like large layered domes of rock. They are the oldest visible evidence of life on Earth. Each layer was built by generations of cyanobacteria growing towards the sunlight. For billions of years, these humble microbes were the most advanced life form on the planet. They were tiny, but together they formed a living film that was slowly wrapping the world in a blanket of green. Photosynthesis had a very important side effect. When cyanobacteria used sunlight, water, and carbon dioxide to make their food, they produced a waste product. This waste was a gas, oxygen. For the cyanobacteria, it was just something to be released into the water. They had no use for it. But for the planet, this simple act of breathing out was the beginning of a global transformation. Every day, for millions and millions of years, these tiny factories pumped a new and powerful gas into the oceans. The world was not prepared for what was coming. The very air was about to be remade. Section 3. The slow poisoning of the world. At first, the oxygen produced by the cyanobacteria did not build up in the atmosphere. Instead, it immediately reacted with other elements in the ocean. The ancient seas were full of dissolved iron. When oxygen mixed with this iron, it created rust. For hundreds of millions of years, this rust fell like a slow, reddish-brown snow to the bottom of the ocean. It settled in thick layers, trapping the new oxygen in solid rock. These layers formed immense deposits of iron ore, which we mine today. They are a silent record of the first breath of our planet, a rusty memorial to a changing world. You can see this history written in the rocks. If you look at ancient rock formations, you can find layers of dark rock from the time before oxygen, followed by beautiful red-striped rocks called banded iron formations. These bands show the seasonal blooms of cyanobacteria. In the summer, they would produce a lot of oxygen, creating a layer of rust. In the winter, they would produce less, creating a darker layer of mud. This cycle repeated for nearly 1 billion years. The oceans were slowly being cleared of iron, one rusty layer at a time, as the cyanobacteria continued their work. This long process was life's first great engineering project. The cyanobacteria were unintentionally cleaning the oceans. They were taking the dissolved iron, a key feature of the early seas, and turning it into solid rock on the sea floor. This was a slow and steady transformation. While it was happening, the oxygen levels in the water and the air remained very low. All the oxygen being made was immediately captured by the iron. The planet was like a giant sponge, soaking up the new gas as fast as it was produced. But no sponge can soak forever. Eventually, after more than 1 billion years, most of the iron in the oceans was used up. The rust had all settled to the bottom, but the cyanobacteria did not stop. They continued to perform photosynthesis, and they continued to release oxygen. Now, there was nothing left in the ocean to absorb it. The oxygen began to bubble out of the water and escape into the sky. For the first time in Earth's history, free oxygen started to build up in the atmosphere. For the other forms of life on the planet, this was a catastrophe. Oxygen was a toxic, corrosive poison. Section 4. The Great Oxygenation Event. The buildup of oxygen in the atmosphere began around 2.4 billion years ago and is called the Great Oxygenation Event. It was one of the most significant changes our planet has ever experienced. For early life that had evolved without oxygen, it was a disaster. Anaerobic organisms found oxygen deadly. It destroyed their cells and broke down the molecules they were made of. The new oxygen-rich air was a poison spreading across the globe. A mass extinction began, the first caused by life itself. A planetary pollution crisis. Waste gas from one organism wiped out much other life. Anaerobic microbes were driven into retreat. They could no longer survive in the open ocean or on the surface. They had to find oxygen-free refuges, deep in the mud on the ocean floor, inside the guts of other creatures, in bubbling hot springs. Their world had been taken from them. The planet now belonged to organisms that could tolerate and eventually use oxygen. The rise of oxygen had another dramatic effect. In the atmosphere, it reacted with methane, a powerful greenhouse gas. Methane had been keeping the planet warm. As oxygen removed the methane, Earth's temperature began to fall. This triggered a massive ice age, unlike anything before. Ice sheets spread from the poles, covering almost the entire globe. The Earth may have become a giant snowball, frozen from pole to pole for millions of years. This was the Huronian glaciation, a direct consequence of the oxygen-filled atmosphere. This period of crisis, poison and ice, was a critical turning point, a harsh filter for life. Only organisms that could adapt would survive. While oxygen killed most old life, it created huge opportunity for new life. Some microbes evolved not just to tolerate oxygen, but to use it. They developed a much more powerful way to get energy from food. This process, respiration, releases far more energy than anaerobic methods. The stage was set for a new kind of cell, one that could thrive in the oxygenated world. In the aftermath of the Great Oxygenation Event, a new and more complex type of cell appeared. This happened around 1.8 billion years ago. We call these new cells eukaryotes, all animals, all plants, all fungi, including us. They were a major step up in complexity from the simple microbes that came before, which we call prokaryotes. One of the key differences was that eukaryotes kept their genetic material, their DNA, safely stored inside a central compartment called a nucleus. This protected the precious instructions for life. The origin of this new cell is a fascinating story of cooperation. It is thought that one large, simple cell tried to eat a smaller one. But instead of being digested, the smaller cell survived inside the larger one. The two cells formed a partnership. The smaller cell was a microbe that had adapted to use oxygen for energy. It became a permanent resident, living inside the larger cell and providing it with abundant energy. In return, the larger cell provided protection and raw materials. This arrangement was so successful that it became permanent. These tiny residents, the former oxygen-breathing microbes, became what we now call mitochondria. They are the power plants inside all of our cells. Every breath you take delivers oxygen to the mitochondria in your body, which use it to power everything you do. This ancient partnership gave eukaryotic cells a huge advantage. With so much extra energy, they could become much larger and build more complex internal structures. They could afford to have a nucleus, and they could build and maintain a much larger and more complicated set of genetic instructions. This new type of cell opened the door to another great leap for life, multicellularity. With more energy and better organization, cells could start working together in groups. At first, they may have just clumped together in simple colonies. But over time, some cells within these colonies began to specialize. Some might focus on movement, while others focused on feeding or reproduction. This division of labor was the beginning of true multicellular organisms. For the first time, life was more than just a collection of single cells. It was becoming a team, paving the way for the first animals. For nearly 3 billion years, life on Earth had been simple. It was a world of microbes, algae, simple, soft-bodied creatures floating in the sea. But then, around 541 million years ago, something remarkable happened. In a relatively short period of geological time, the ocean suddenly filled with a dazzling variety of complex animals. This event is called the Cambrian explosion. It was as if a switch was thrown and life's creativity was unleashed. For the first time, animals with shells, legs, claws, hard skeletons appeared in the fossil record. The sea, once quiet, was now teeming with new and strange forms. What caused this sudden burst of evolution? The reasons are complex and still debated by scientists. Oxygen levels in the atmosphere and oceans had finally risen enough to support larger, more active bodies. The end of a global ice age may have released a flood of nutrients into the sea, providing more food. But a key innovation was predation. Animals began to hunt and eat other animals. This started an evolutionary arms race. Prey animals developed defenses like hard shells and spines. Predators evolved better attack tools, sharp claws, complex eyes. The world of the Cambrian period was a strange and wonderful place. On the seafloor crawled trilobites. They looked like armored woodlice. They were hugely successful, and their fossils are found worldwide. Swimming above them were sci-fi-like creatures. One was Anomalocaris, a giant predator with 2 large grasping claws and large compound eyes. Life was experimenting with countless new body plans, new ways of moving, new ways of seeing, and new ways of surviving. Many experiments failed, but others set the course for all future animal life. This explosion laid the groundwork for the animal kingdom as we know it. Almost all major animal groups trace roots to this frenzy. The first creatures with a primitive backbone appeared, ancestors of fish, amphibians, reptiles, birds, mammals. The Cambrian explosion was not the beginning of life, but the beginning of animal life in a form we would recognize. The oceans were no longer just a chemical soup. They became a complex ecosystem of flesh and stone, filled with hunters and the hunted. For billions of years, life had been confined to the oceans. The land was a barren and hostile place. It was a world of bare rock, sand, dust, baked by the sun's unfiltered ultraviolet radiation. There was no soil, no plants, no sound, but the wind. But the oceans were becoming crowded and competitive. The land represented a vast, empty continent of opportunity. The first life to make the journey out of the water was likely simple algae, lichen, forming green crusts on wet rocks near the shore. They were the pioneers, slowly preparing the ground for what was to come. Then, around 470 million years ago, the first true plants arrived on land. They were small and simple, like modern mosses. They had no deep roots, no leaves, no flowers. They had to stay close to water to survive and reproduce. But they were a revolutionary force. As these first plants died and decomposed, they created the very first soil. This thin layer of organic matter held onto water and provided nutrients. For the first time, the bare rock of the continents began to be covered by a thin, green fuzz. The slow greening of the world had begun. Over the next 100 million years, plants evolved and adapted to their new home. They developed roots to anchor themselves and draw water from the soil. They grew stems to lift themselves up towards the sunlight, competing with their neighbors. They evolved leaves to capture more of that light. And they developed a vascular system, a network of tiny tubes to transport water from their roots to their leaves. This allowed plants to grow much taller and to move further away from the water's edge. By about 385 million years ago, the first forests had appeared on Earth. The arrival of plants fundamentally changed the planet. The new forests pumped even more oxygen into the atmosphere, reaching levels even higher than today. The roots of plants broke up rocks and stabilized the soil, preventing erosion. This changed the way rivers flowed and how sediment was deposited. The land was no longer a dead and empty landscape. It had become a living, breathing habitat. And where the plants went, the animals would soon follow. The greening of the land set the stage for the next great migration in the story of life. With the land now covered in plants and the air rich with oxygen, it was only a matter of time before animals left the water. The first to venture onto land were probably small invertebrates, scorpions, and giant millipedes. They found a world full of plants to eat and very few predators. But the real pioneers were the fish. Some fish living in shallow, swampy water had evolved fleshy, lobe-like fins that they could use to prop themselves up. They also had primitive lungs, allowing them to gulp air from the surface when the water was low in oxygen. These adaptations were the first steps toward a life on land. Around 375 million years ago, creatures appeared that were part fish, part land animal. A famous example is Tiktaalik. Gills, scales, fins like a fish, a flat skull, flexible neck, and fins with the bone structure of a limb, complete with a wrist. It could push itself up, move around in the shallows, perhaps even haul itself onto the mud. These were the first amphibians. Over millions of years, their descendants spent more and more time out of the water. Their fins became legs, and they began to explore the new green world. This period, known as the Carboniferous, is sometimes called the Age of Giant Insects. The high oxygen levels in the atmosphere, perhaps over 30%, allowed insects to grow to enormous sizes. Dragonflies with the wingspan of a seagull, millipedes over 6 feet long, crawling through giant fern forests. The amphibians also grew large. They were the dominant land predators, but they were still tied to the water. They had to lay their soft, jelly-like eggs in ponds and swamps, just as modern frogs do. Life had conquered the land, but it still had 1 foot in the water. A crucial innovation finally broke this tie to the water. Around 320 million years ago, some animals evolved the amniotic egg, an egg with a tough, protective shell that prevented it from drying out. Inside, the embryo floated in its own private pond. This was a revolutionary invention. Animals no longer needed to return to the water to reproduce. They could now live their entire lives on dry land. These new animals were the first reptiles, true conquerors of the continents, and soon to dominate the planet, setting the stage for an even greater age of giants. With the invention of the amniotic egg, the reptiles quickly spread across the globe. They became the dominant land animals for an incredibly long time. This entire era of Earth history, from 252 to 66 million years ago, is known as the Mesozoic era, or the Age of Reptiles. During this time, the continents were slowly drifting and rearranging themselves. They were joined together in one giant supercontinent called Pangaea. The climate was generally hot and dry, a perfect world for these new, fully terrestrial creatures. The stage was set for the rise of a truly spectacular group of reptiles. The first dinosaurs appeared around 230 million years ago. They started small, many no bigger than a dog. But they had a key advantage. Their legs were positioned directly underneath their bodies, rather than sprawling out to the sides like other reptiles. This allowed them to move more efficiently and to support a much larger weight. Over millions of years, they grew to incredible sizes. Long-necked sauropods like Brachiosaurus, the largest animals ever to walk the earth. Stegosaurus, Triceratops, Tyrannosaurus rex. For 150 million years, dinosaurs ruled the planet. They were a hugely successful and diverse group of animals. They filled every habitat on land, from the polar regions to the equator. Some were enormous, shaking the ground with every step. Others were as small as chickens, scurrying through the undergrowth. While the dinosaurs dominated the land, other reptiles took to the skies and the seas. Flying pterosaurs with their leathery wings soared through the air. Ichthyosaurs, plesiosaurs. It was a world ruled by reptiles in all their magnificent forms. While the dinosaurs reigned supreme, other smaller creatures lived in their shadows. Among them were the first mammals. They were small, furry, mostly active at night. They survived by being secretive and staying out of the way of the giant rulers of the world. For millions of years, they remained small and insignificant, a minor part of the global ecosystem. No one could have guessed that their time would come. But the history of Earth is a story of sudden change. The long, stable reign of the dinosaurs was about to come to a sudden and catastrophic end. Section 5. The Great Dying. The history of life has not been a smooth, continuous progression. It has been punctuated by several moments of global crisis, known as mass extinctions. These are times when a huge percentage of all species on Earth disappear in a relatively short period. The most severe of these events happened long before the dinosaurs. It occurred 252 million years ago, at the end of the Permian period. This event was so devastating that it is often called the Great Dying. It was the closest life has ever come to being completely wiped out. Over 90% of all species in the oceans, 70% of all land animals vanished forever. The cause of the Great Dying was a period of unimaginable volcanic activity in what is now Siberia. For thousands of years, enormous fissures in the Earth's crust poured out a sea of lava that covered an area the size of Europe. This released colossal amounts of carbon dioxide and other greenhouse gases into the atmosphere. The planet heated up dramatically. The oceans became warm and acidic, and they lost their oxygen. It was a global catastrophe that unfolded over thousands of years, suffocating the land and the sea. Life on Earth was pushed to the very brink of extinction. It took millions of years for the planet to recover from this disaster. The world that emerged was very different. The old forms of life were gone, leaving a vast ecological void. This emptiness created an opportunity for the survivors to evolve and diversify. It was in the aftermath of this great extinction that the first dinosaurs began their rise to power. The Great Dying, in a sense, cleared the stage for the Age of Reptiles. It is a powerful reminder that in Earth's history, moments of destruction often pave the way for new forms of life to flourish and take over the world. The end of the dinosaurs came much later, in another mass extinction 66 million years ago. As we saw at the beginning of our story, this was caused by a massive asteroid impact. While not as severe as the Great Dying, this event was much more sudden. It plunged the world into darkness and cold, causing the collapse of food chains across the globe. All dinosaurs disappeared, except for one group that would evolve into birds. The giant marine reptiles vanished, and the flying pterosaurs also vanished. The long reign of the reptiles was over. The world was now quiet, empty, and waiting for new rulers. Table of Contents, Part 5, Conclusion, about 3 section. Section 1. The Age of Mammals. The world after the asteroid was empty and quiet. The great dinosaurs were gone. The long 150 million year reign of the reptiles had come to a sudden and dramatic end. In the quiet forests and empty plains, small creatures began to emerge from the shadows. These were the mammals. For millions of years, they had lived a secretive life, scurrying in the undergrowth, mostly active at night to avoid the giant rulers of the day. They were small, furry, and warm-blooded. With their main predators now gone, a world of opportunity opened up before them. The age of mammals had begun. In the millions of years that followed the extinction, mammals began to diversify in spectacular fashion. They evolved to fill the empty roles left behind by the dinosaurs. Some grew large, becoming the new dominant herbivores on the plains. Others became powerful predators, hunting these new plant eaters. Mammals returned to the sea, evolving into the ancestors of whales and dolphins. They took to the air, becoming the bats that fill our night skies. From a few small, shrew-like survivors, they exploded into the incredible variety of forms we see today, from the mighty elephant to the tiny mouse. One group of mammals took to the trees. These were the primates. Life in the trees required a specific set of skills. It required hands that could grasp branches and eyes that faced forward to judge distances accurately. This binocular vision gave them depth perception, essential for leaping from branch to branch. Living in complex three-dimensional forest environments may have also encouraged the development of larger, more complex brains. For millions of years, our distant primate ancestors lived this life, high in the canopy, slowly evolving the traits that would one day define our own species. Then, the world began to change again. The climate grew cooler and drier. In Africa, the vast forests began to shrink, replaced by open grasslands and savanna. This change in the environment presented a new challenge for our ancestors. Some primates stayed in the shrinking forests, but one group was pushed out onto the new, open plains. To survive in this new world, they had to adapt. They left the trees behind and began to walk on 2 legs. This was a pivotal moment. Standing upright allowed them to see over the tall grass, to spot predators, and it freed their hands for other tasks. Section 2. The Human Planet. Freed from the job of walking, our ancestors' hands could now be used for new purposes. They began to make tools. At first, these were simple, sharp-edged stones, used to cut meat from bones, break them open for the rich marrow inside. This was the beginning of technology. Over hundreds of thousands of years, these tools became more and more sophisticated. The ability to create and use tools drove our evolution. Social cooperation needed for hunting. Social cooperation needed for defense. This was the dawn of humanity. Several different species of early humans, or hominins, walked the earth. They lived alongside each other, sometimes competing, sometimes coexisting. But one species, Homo sapiens, proved to be uniquely successful. We emerged in Africa around 300,000 years ago. With our large brains, we developed complex language, allowing us to share knowledge, plan for the future, build strong cultures. We learned to control fire, giving us warmth, protection from predators, and the ability to cook our food. These abilities gave us an unprecedented advantage, allowing us to adapt to almost any environment on Earth. About 70,000 years ago, small groups of our ancestors began to migrate out of Africa. They spread across the globe with surprising speed. They moved into Asia, across to Australia, into Europe, and finally, across a land bridge into the Americas. No other species had ever colonized the planet so completely and so quickly. Everywhere we went, we adapted, we innovated, and we thrived. We survived ice ages, hunted giant beasts, and painted their images on the walls of caves. We were no longer just another animal. We were becoming a new force of nature, a planetary scale influence. Then, about 10,000 years ago, we made another revolutionary leap. We learned to domesticate plants and animals. This was the invention of agriculture. We no longer had to wander in search of food. We could settle in one place, grow our own crops, and raise our own livestock. This led to the first villages, then the first cities, and the first civilizations. Our population began to grow rapidly. We built roads, dammed rivers, and cleared forests. In the last few centuries, with the Industrial Revolution, our power to change the planet has grown exponentially. We have become the single dominant force shaping the future of life on Earth. Section 3. Our place in time. Our journey through 4.5 billion years is now complete. We have seen Earth form from a cloud of dust, a violent ball of fire, that cooled into a water world. We witnessed the first spark of life, a tiny microbe that would lead to all the diversity we see today. We saw that life itself transformed the planet, creating the very air we breathe. We watched as life exploded in the oceans, crawled onto the land, and grew into the magnificent forms of the dinosaurs. We have seen worlds rise and fall, and we have seen how moments of cataclysm and extinction cleared the way for new beginnings. The story of our planet teaches us three profound lessons. The first is the lesson of change. Continents drift, climates shift, and life adapts or disappears. The world we see today is just a snapshot in a very long film. Nothing is permanent. The second lesson is resilience. Life has survived unimaginable catastrophes. It has been frozen, poisoned, and struck from the heavens. Yet it has always found a way to bounce back, to recover, and to radiate into new forms. Life is tough, tenacious, and incredibly creative. But the third lesson is that of fragility. While life as a whole is resilient, individual species and ecosystems are not. The dinosaurs were rulers of the Earth for 150 million years, but they were wiped out in a geological instant. The history of Earth is a graveyard of countless species that are gone forever. This brings us to our own time. In just a few thousand years, our single species has begun to alter the planet on a scale comparable to some of the great natural forces of the past. We are changing the climate, altering the chemistry of the oceans, and causing the extinction of other species at an alarming rate. Our unique intelligence and awareness give us a responsibility that no other species has ever had. We are the first form of life on Earth that can understand its own history. We can read the story written in the rocks, and we can see our own impact on the world around us. This knowledge gives us a choice. The future of this small blue dot is now in our hands. After 4.5 billion years of fire, ice, and life, we are the ones who will write the next chapter. We can choose to be a force of destruction, another great dying, or we can choose to become wise stewards of our only home, ensuring that this incredible story continues long into the future.